This lesson is going to be a little short because I covered most of it in the previous lesson. I got a little carried away in the previous lesson and I jumped into this material. So let's take a look at this. And this lesson is called I Love Pure Functions. They Cannot Lie. And as I note here, I initially thought pure functions were nice. But then when I started using them, I thought, wow, this is important. Input goes in the front door, output comes in the back door. And as I've noted previously, there are no side doors. There's nothing going on over here. It's just data in and data out. And my overwhelming thought was pure functions can't lie. You can look only at the signature of a pure function and know what it does. You don't have to dig into the source code of impure methods. You just have to look at the function signature. And this hit me so hard. One of the first things I wanted to do is create this impure annotation, but I knew I had no way to enforce that. So I kind of experimented with that a little bit. And I said, well, I wanted to be able to identify impure functions. So randomInt, as written here, is an impure function. But again, I knew I had no way to enforce that. So it was just a marker annotation, and that wasn't very helpful. And what I further found is that pure functions reduce your cognitive load. And what I mean by that is when you write a pure function, the only thing you have to think about, your entire universe when you're writing is what input parameters come in, what is the pure function's return type, and what is my algorithm. So literally, the only thing I'm thinking about when I write a pure function, I show in this area here, input parameters, the algorithm of the function, and then the return type. And you don't have to worry about, mutating global variables or, if I touch a variable inside of here, am I changing something in the outside world? Because again, we don't mutate anything that comes in. So if everything comes in the front door and I can't mutate it, the only thing I have to worry about is right here. So as I note right here, you just have to think locally. And once I realized that, even the imposter syndrome in me thought, I don't know if I can write an entire application today. I'm not really feeling great, but I know I can write one pure function, and then maybe I can write another pure function and another. And then maybe later today or some other day, I can eventually glue all these pure functions together to solve bigger problems. And as I note here, gluing pure functions together is just like algebra. And functional programmers use terms like compose or composability to refer to this ability right here. And another key about this is not just does it reduce your cognitive load, but I find that I like reading the signatures of pure functions that other people write. So I mentioned earlier in this course about some problems I had with OOP style methods, and especially those that return void and they don't take any input parameters. Those things make their type signatures meaningless. But when you look at the signature of a pure function, you can guess at a glance, just by looking at that type signature, what's going on inside that function. And I did mention this in a previous lesson, so I won't belabor it, but a fun game I like to do is look at a pure function and you can guess, well, what can this possibly do? And again, you know that the entire universe of the function is a list of integers coming in and an int going out. And that gives you a really good clue about everything you can do. So I have a little quiz here that you can write down everything you think that the pure function can do. And that's a fun exercise. And then another fun one is you expand that a little bit and you say, well, let's look at the same function signature, but now I'm using a generic type here. So this can be any sort of list coming in. It can be a list of int, string, double, float, whatever. And then the thing that's returned from that function is also that same generic parameter a. So whatever this function is doing, it's this type and this type are exactly the same. So if this is a list of string right here, then this has to be a string here. If that's a list of int, that has to be an int, so on. And again, a great exercise is write down everything you can think of that this pure function can possibly do. And a key point here is that this exercise doesn't work if the function body can reach out into the outside world. So again, if it's reading global parameters from somewhere else or mutating global parameters or reading input from somewhere or writing output from somewhere, this function signature has a lot less meaning. But when you know that it's a pure function, you can play this game of what can this pure function possibly do. So to summarize this, and again, this is from the last two chapters, or in this case, the last two video lessons, pure functions reduce your cognitive load because all you have to do is think about your local world and the variables coming in, your algorithm, and your output. And then you can trust pure functions. They can't lie. Their signatures tell you exactly what they can and can't do. And this makes reading pure function signatures much easier and much more meaningful from type signatures from impure functions. And the last point I'll make, and I repeat this many times in the book, and I'll do the same thing in these video lessons, is that writing code using pure functions and then gluing them together feels just like writing algebra. So you start by writing a few pure functions like this, and then you glue them together. So you have an algebraic expression right here that assigns a value to x, and then you use x in the next expression, and then so on. So all of your code is just like this. It just feels like one algebraic expression after another. And if you don't like the comparison to algebra, another way to think of this is that you could be creating a blueprint. So it's a little bit like you're an architect or an engineer, and you're creating a blueprint, a very simple blueprint. Again, nothing here throws an exception, so it doesn't, blow up your code and throw your code out to a try-catch exception. It just goes from one line to the next, to the next, to the next. So if you're not familiar with functional programming and pure functions, I hope this has been helpful. And again, part of this is to define what pure functions are, and then the other part is to share these benefits with you. And maybe another part after that is to kind of get this mental model built up in your mind of what pure functions are and what functional programming is as we enter the following lessons.